So in today's video, we are explaining how to solve the equation of the type cos x equal to c, such that c is a real number. So like we have seen before, if the number c is not included in the interval -1, 1, then this equation has no solutions. Okay, let's say, for example, if I want to solve, let's say we solve cos x equal to 3/2, let's say, in R. Okay. Now, in this situation, I have just to state that whatever my number in R, the image of my number by the function cos is between -1 and 1. So the image of any real number that can imagine will never be equal to 3/2 in this case. Thus, the equation cos x equal to 3/2 has no solutions in R. So I have nothing to do. I don't need to solve or try to solve. I have just to read, understand my equation, and see that it has no solution, because whatever my is always between -1 and 1. In the case that the c is my number c is between -1 and 1, so if I'm solving in R, okay, if I'm solving in R, I'm going to use this property. I'm going to use this property to do the job. Okay. So this is one example. If I want to solve the equation cos x equal to -12 in R, so -12 is a value, -12 is a value between -1 and 1. So this equation has solutions. So we have to look at this particular value, which is -12. Do we know the cost of some value in R which equal to -12? So it's -12 is a well-known value for us. So I know that cos of 2 pi over 3 equal to -12. So in this case, my alpha that I have to look for is equal to 2 pi over 3. And I start using my property. So cos of x equal to -12. This comes to say that cos of x equal to cos of 2 pi over 3. So it's either we use 2 pi over 3 or the opposite of it, because the cos function is an even function. Then straightforward application, and then getting my set of solutions. So my conclusion, thus the set of solutions is, I'm going to call it F0 here as well, is this one. So right, curly bracket. So it's not my curly brackets. So here I have a -2 pi over 3 plus 2k pi. And here I have 2 pi over 3 plus k pi, such that k take all possible values in z. Okay. So this is one example where the value, okay, the image of 2 pi over 3 is actually equal to -1. So this is how to solve in R, this example. Now, if I'm trying to solve some given interval, so I could do the job algebraically. It means I solve in R first, then I do the intersection between the set of solutions that I obtained in R with the interval I'm doing the job in. Then I give my final conclusion. Or I can use straightforward the second method, where I use the unit circle to do the job. Okay. So for this example here, I'm going to show you the second method only, because we have the previous video, we did show the first method for equation sine x equal to c. Okay, so this is the second method. These are the steps. Okay, so the first step is to draw the unit circle as it is shown here, right? You see here on the left side. So after drawing a nice unit circle, it's not nice at all, right? It's just I try to do my best, still to use the features of this software, right? So I do shapes, I add my axes, right? And I try to draw some nice symbol. So of course I don't have my looks nice symbol, right? And oops, there's a pin. Oh, sorry, only in the eraser. Oh, why only the eraser? Okay, still holding the eraser. What's that? I don't know. Why I can always see something wrong. I don't know why. Never mind. We just go there, go there. Okay, and then move it now. Not move it now. Just take the eraser, erase this. Go to and move it. No, never mind. I was just joking. This is my circle. This is my axis, right? So the steps is that we draw the unit circle first, then we draw the line of equation x equal to negative half. So this is 0 here, this is 1 here, on the axis, huh? Okay, on the x and y axis. Okay, so my line is the line of equation x equal to negative half. So negative half is somewhere here. Then I draw the line of equation x equal to negative half. So this is the line of equation x equal to negative half, which is c in my case here is negative half. Okay. I find the point of intersection between this line and my unit circle, and I try to figure out what are the values associated with these. So I can use my protractor to find out, or if I have the idea, I would know that the value here should be 2 pi over 3, and by symmetry, the value here is going to be minus 2 pi over 3. So all the possible values is plus 2k pi. Accepting all the possible values. So it's plus 2k pi, and here it's plus k pi. And these are the solutions in R. Okay, so then I go and find my interval is from 3 pi to 5 pi. So the point corresponding to 3 pi is actually this one, and the point corresponding to 5 pi is the same point. So this is my starting and ending point. Then I should calculate the number of flaps I'm doing. So A equal to 3 pi, B equal to 5 pi. I would calculate B minus A equal 5 pi minus 3 pi, which is equal to 2 pi. If I divide this by 2 pi, I get 1. Then I'm going to do exactly 1 lap. It means I start at this point, I go around, I do 1 lap, then I'm done. Okay. So how to do the reading? I start going around, starting from this position. So I'm going in the positive direction. Okay, we go always with this point, okay, in my interval. Okay, so how to get the video here? So I can do it in different ways actually. Okay, so I can see that this distance here from this point to this point, this distance here is equal actually to 2 pi over 3. So this distance here is equal to pi over 3. It's different color. So this distance is pi over 3. Talking about the distance. Okay. So my videos will be like 3 pi plus pi over 3. And I go around, I reach here, then the video here is 4 pi. Then it's 4 pi plus 2 pi over 3. 4 pi plus 2 pi over 3. Then I reach my point again, then I hit stop. Then this equation in this interval, it has exactly two solutions. What are they? So it's 10 pi over 3 and 13 pi over 3. Okay, so how can I get my video at this point in a different way? At this point, we have the video associated with 3 pi. So we can go till this point. So this point is well-known point, call it usually I. Then video, so with I is 4 pi, then it's 4 pi minus 2 pi over 3. So this value, I can say it's 4 pi minus 2 pi over 3. So whatever the way we do the job, we are going to get the same values anyway. Okay, so this is me doing the steps. So the steps are here. Okay. So there's a mistake here. Right? Yeah. Okay. So here for the conclusion. Okay. Conclusion is not a good one. Okay, it's okay. Here it's okay. Because I can just go till 5 pi. I may start this point, go to 5 pi, go back pi over 3, get my second video. So here, sorry, the conclusion is not a good one. So using the simple, okay, I'll just write my conclusion here, right? Using the unit circle, the solutions of cos x equal to negative half in I, in my interval, are 10 pi over 3 and 13 pi over 3. So what is very important is that you don't have to do a lot. Only what you need to do is to draw this actually. Well, sorry, is to have this. Okay, you draw your only circle nicely. So my drawing here, I didn't make it like crowded, a lot of practice there, so I was explaining. But when you do your job, you don't have to put a lot of values there. Okay, all you need to do is just to do something simple, right? Put your points, group your interval, do the reading, give your conclusion. It should be quite straightforward. Okay, so that's all for this video. Thank you for listening.